Okay, guys, 1 second. Let me go back. So in the previous class, we have seen about catalyst optimizer, right? So we have left with one concept about the clusters here. Okay. So we are going to see what is a cluster, how cluster will be created, what are the options that are available that we are going to see here now. Let me open the slides.
Sir, can you just recap the last class, Catalyst Optimizer?
Okay. So you have any doubt or you want to recap?
I just want to recap, sir.
Okay. Have you done practice?
For till workflow, sorry, this data frame fifth exercise till that I did, and I couldn't recap this Catalyst Optimizer. I just,
Okay. You just go through the recording. If you have any
yeah,
questions, come to me. Okay.
yeah, sure, okay, sir.
See, I can explain only a number of times,
Yeah,
but
yeah, no
if you
issue.
go through that, if you are not able to understand, then
No,
it's
actually,
yeah,
you used to recap every class, no, for next first 5 minutes, so that's why I
yeah,
mentioned.
that's fine. Okay,
Yeah,
and I'm saying like whenever I complete today, make habit of completing that topic before we start next class. Okay, so what
yes,
happens, right? Sometimes you'll get some doubts. Then I can explain the thing, not an issue. Okay, that
sure,
is
sir.
what my intention here. Okay, it's not like you are not going through. Okay.
Yeah, yeah.
Okay. So Catalyst Optimizer is one of the performance optimizer which is available in data frame, dataset, and RTD. So if you go here, whenever you read any file, whenever you read any dataset, or whenever you store some data in the SQL, okay. So what happens, right? It will be stored in the data frame, dataset, or SQL Analytics. So what happens? You write the code. So what happens? First of all, this catalyst optimizer will analyze. So we will get your code, unresolved logical plan. It will read the your plan, and then it is going to get the data catalog about what is the database or what is the file, what kind of metadata it has, what kind of data type it has, how the code has been done. So it will get all the catalog information, and it is going to provide the to logical plan which is available in the catalyst optimizer. So once this is there, so what happens? It will provide logical optimization. Means it is going to provide you optimized logical plan. Means it will suggest based on your code, it will suggest go with this code, rewrite your code. So it will provide us this optimized logical plan. Is going to provide you the input. Please prepare the. Please rewrite your code in this format. And finally, once we have this, you need to implement that physical plan, whichever the plan that is going to get from optimized logical plan, and then you need to execute this. It will do the code generation for you. So if you want to see how this logical plans works, then what you need to do, you need to use once after writing the code. Suppose I have written this code here. I have written the code here, right? So I have written a number of codes here. Okay, so I have this code here. Okay, so if you see here, so I'm every filter, I'm going to write the data to this data frame. So what happens? My data will be available here, and it is going to print each and every data frame, which is wrong way of doing this coding. So instead of writing the data to each and every data frame, I am going to write the filter conditions while reading itself, and I'm going to write into another data frame. So here I'm just skipping the count for each and every data frame. I'm using filter operation. If you want to see whether this code is optimized or not, you need to use explain command, which is available. Data frame dot explain true. It is going to provide you the parse logical plan, analyze logical plan, and you have this optimized plan. So this is where optimized logical plan will suggest you how to rewrite this code. So they're saying like use filter for once and write uncondition for each one. So you need to rewrite your code in this format. So this is how Catalyst Optimizer is going to work for you. So this is any questions here?
No, sir, I understood.
Yeah. Yeah. So now we have left with cluster. So we have left with cluster. Okay. So if you see in the Databricks, what happens, right? There are two things that will be available internally. Whenever you onboard any Databricks, there is a control plane and there is a resource manager. One is data plane, one is data plane, one is control plane. So what is this control plane? What is data plane in the sense? Whenever you onboard Databricks, so let me go here. So this is in terms of administrator, but I'm explaining you how it works. So if I onboard any Databricks here, right? So when I go here, so whenever you onboard this Databricks, what happens, right? So this will be divided into two things. One is control plane, one is data plane. So what is a control plane in the sense? In the control plane, your cluster manager will sit Databricks cluster manager, Databricks UI, UX, DBFS, and all this information is going to sit in the control plane in Databricks subscription. This control plane you can't see here. You can't see here because this is my subscription. But whenever you onboard the control plane, whatever the control plane that it has here about Databricks cluster manager, okay, Databricks UX, DBFS, these clusters, everything is going to sit in Databricks subscription in different subscription. Which customer don't have the control over of this? Which customer won't have control over of this? This will be purely taken care by the Databricks team. And if you see the data plane, if you see the data plane, so this data plane will be having about the notebooks, Databricks workspace, blob storage, VMs. So everything will be under your own control. Everything will be under your own control. So you can have access to our workspace. So that is what we see in the data plane. So data plane, you can have the customer subscriptions. If you see, this is data plane. You can see this is my customer subscription, my subscription. And if you go here, we have managed resource group. This, if I go here to this Databricks resource group, so it is going to see, so this entire thing like VM creation, this everything is under customer your control. So you can see all these strings, like whatever I have created, identity, storage account, workspace, network, NSG groups, and network version, everything can be created here in the data plane, which is available here. So you can do all these stuffs in the data plane, but control plane, whatever you store the data in the control plane, like about cluster information, this cluster information will be stored in this Databricks subscription, cluster manager. So everything will be stored in the Databricks subscription. So this is one of the important thing that you should know as part of administrator. As part of data engineering, you should know only data plane, all the notebooks, like VM's Databricks workspace, whatever the workspace we have, all the things will be sit under your shared, all these things will sit under your own control. Blob storage will be connected, sorties will be under control. The cluster will consist of VM. That VM is going to sit inside your thing. And NSG. So we have seen here, right? NSG, VM, VNet. So all these things are going to sit here. So if you see network resource group, virtual networks, storage account, all these things are going to sit under data plane. Okay. Now, if you see what is the clusters. So clusters, what is the database cluster we have? How many types of cluster we have? How to configure the cluster? How to create the cluster? Pricing, cost control, cluster pools, and cluster policies. So these two things is not important, but you should know first 6 things. So if you see a cluster consists of driver and worker nodes. So whenever you create any cluster, in the Databricks, whenever you create any cluster in the Databricks here, right? So if you see, where is my thing? Whenever I create any cluster in the Databricks, a separate VM will be onboarded for you. Whenever I launch this workspace, right? is not showing anything here because this cluster has been stopped. So whenever you create any cluster here, whenever you onboard any cluster, so I'll show you this. Whenever we a cluster from the backend, virtual machines will be created and Databricks will be onboarded in that. So if I go to the Databricks resource group, so if you see inside this resource group, so you have storage account, network, so all these things will be created for you. So this is the resource group will create. This manage resource group will create for each and every Databricks workspace that you create whenever you are onboarding. So this will be managed by Databricks. You should not worry about this thing. So the VM I'll show you. So whenever you will create the cluster from the backend in Azure portal, the VM will be created and this compute cluster will be created for us. So a VM consists of this cluster consists of driver and worker nodes or executors we call. So what is this driver and worker nodes in simple terms? Simple terms. So let me go back. Let me explain this thing first. So you need to go to extras, Spark architecture here. So here, the Spark architecture. So if you see here, so whenever you read any file, CSV file using Spark or any JSON file, the file will read and it will give the work. It will distribute the work to the multiple worker nodes. And these worker nodes will do actual reading of your data. And finally, this data will be returned to either Amazon S3 or blob storage, any storage or any disk. So if you see here, the concept of drivers and executors in the thing is
Sir, you're speaking, right?
no. Sorry guys,
Okay,
my
okay.
kid is doing some noise here.
Okay,
Sorry
no
for
problem.
that.
I thought we lost some voice. That's what.
No. I stopped here. Okay, I kept on mute because it will be on recording, right? So I don't want to disturb them. Okay. So if you see the Spark operation, Spark application has broken down into two things. One is driver and executor. So whenever you read any file from the backend, whenever you attach to the cluster, that cluster will consist of driver and executors, multiple executors. It will be the one driver and it will be the multiple executors that are available in our cluster. So only one driver per application. You might get one question in interview question. So how many drivers are available? So you should always one driver per application and you can have multiple executors. So what this driver is going to do?
Sir,
What this,
just a question.
yeah.
Sir, so suppose we have commands in the notebook, right? So suppose if we run two commands one by one and both are running parallelly, so we have called two driver on only one driver is working.
Have you tried executing two commands at a time in a notebook?
Yeah, I saw you multiple times that you
In the single notebook or two notebooks?
single notebook, sir, same
Single
notebook.
notebook always, even if I execute all the commands at once, whenever
Mhm.
first command completes, then only the second command will execute.
Okay, it
The
means
second
only one
command will be
driver.
keep on waiting. It will be sequence in the application.
Okay, sir. So
Okay.
only one
Good.
driver is associated with one notebook, one open notebook, I would say, right?
Not notebook, per application. See, I have this notebook. I have this workspace. I can
Okay,
have 10 notebooks. I can run 10 notebooks parallelly.
okay.
Okay.
Hmm.
But your question is like you were confused here. Okay. So you have a driver here. So wait for this topic to complete so you'll get clarity. What is the driver? Okay.
Okay, sir.
Okay. So if you see here, so your question will be answered by end of this thing. You will only get the answer for that. Okay. So what is driver? So we have driver and executors. We have always only one driver for single JVM process. And you can have a number of executors, which is actually performing your distributed work. Distributed work they are going to perform. So if you see clearly, broadly speaking about the driver, so what driver is going to do? Suppose I have this code. I have this submitted this code. So I have written this code and I have this code. So whenever I click attach the cluster and when I click on run cell, this job is going to submit to the driver. This job is going to submit to the driver. If you run this command, if this command is running, if you run this command, so what happens? This command is still running and this will be keep on waiting until this gets completed. That is one thing. If you have 2 or 3 notebooks separately, so suppose you are running one notebook, Surendra is running one notebook, I am running one notebook, 3 notebooks, and I am attaching the same cluster. So you can submit the applications parallelly. This command, this execution is specific to the notebooks. So in notebook, if you have 5 commands, it will first run first command, second command, third command, fourth command, fifth command. If you're running 5 notebooks parallelly, that notebooks also is going to work parallelly. It will execute sequentially. Okay. Now, whenever I submit this code to the executor here, when I click on run cell, this code is going to submit to this cluster, which is available, which I have created test 145. And this test 45 has these drivers and executors. So it will have driver and executor. So if you go and see this one, so I have driver and executor available here. So let me attach this. So I'm not getting this option here. So if you see for this one, I have driver and this is a single node cluster. So I have only one driver. I don't have any executors. And it has this much of memory you have. So we'll discuss these things later. Now, what is a driver here going to do? Whenever you submit any code to read some CSV file or anything, it will analyze first your query. It will analyze your code driver. It is going to optimize them. So it will optimize by using Catalyst optimizer or any optimization techniques. It will compile them down to RDD. It will compile either RDD or data frame. It will compile. So if you see, whenever you write Python code, Java code, you need to compile that code. Whenever you write Python code, it will automatically compile, right? Python. The same in Databricks, you've never seen the option to save because it is auto compiled. That driver will take care of that compilation. No need of any compiler here for Spark. Databricks will take care of that. Compile them, this driver will take care of that. And it is going to see how the work should be parallelized. How I need to split my work. Suppose if I'm going to read some 1 TB file. So the driver will have plan how, because I have 3 resources, 3 executors, that how to read that 1 GB. So it will distribute, if suppose it is 1 GB or 10 GB, it will distribute 3 GB, 3 GB and 4 GB. So the driver will work how to distribute the work to the executors and how to become parallelism and breaks each job into stages of execution. Means whenever you have the job, if you have 3 or 4 jobs, it will hand over one job to this, and inside the job it will have the stages and stages the task. That's that I'll come picture. So it is going to break down a Spark job into slices and direct the work. So it is going to provide the work to the executors. So in simple terms, driver is nothing but your project manager. So whenever you have any project manager, what you will do? First, you will get the project. You will analyze that project, and you will see what is the cost optimization, that what is the costing for that, and then he will determine how I need to assign that work to the workers, my resources, and then he will break each job into stages to execute that parallelly in the team, and is going to give the work to the workers. So that is what the driver is going to do. It is going to do exactly the manager job here, driver, whenever you submit any code to the cluster. So what executor is going to do? In simple terms, they have assigned some work to you. So you are going to work only that part. You are not going to worry about the work that has given to another colleagues. Executor will actually, in our case, data engineering, the driver will provide all these things, right? So driver, what driver will do? The executor or worker node, it is going to actually work on your data. It is going to do actual work on your data. It will read your file. It will have one or more thread to process a partition. So partitions will be taken care here. And shuffle data each other. So whenever you do group by operations on this, in the code, if you have group by operations, the data will be shuffled across executors. If you do filter and all, it will have narrow transformation. So whenever you want to shuffle the data, you can shuffle the data each other. So it will do, the executor will do. In simple terms, driver will actually analyze your code, optimize that code. You will see how the work should be distributed across executors. So you will take care of these things. Executors will actually work on your data to read some CSV file, partitions, how to handle the shuffles. So all these things will be taken care by the executors here. For any application, for anything, this is the concept. So once you have done, that data will be returned to either ADLS to blob storage or any storage location. So any questions here from anyone?
Sir, this how the partitions I'm like allocated to the executor. I'm like it's automatically like suppose if we have it defines 8 partition should happen for that
See,
data
that is
frame.
what the Spark application will take. That driver will take. Okay, you should not worry about that.
We don't have to look into that. They will
Yeah.
take
If you
care of
want
it.
to, if you want to take that, 1 second, I'm getting one call. Okay, so the partitions will by default, the how many partitions should be taken care by that executors will take care of that. So if to process the partition, they are responsible for reading. So this will be taken care by the executors for you. Should not worry about that. Driver and executor will talk to each other and they will take care of these partitions. But if you want to take care of your own partitions, then you need to use repartition or collapse.
Okay, sir. Uh,
Okay.
Yes, sir. And one more thing, this driver. So as you shown that in our cluster, which is free subscription, we
Yeah.
got only one driver. Okay.
Yes. Yes.
Uh, right. And suppose if we have taken the subscription, paid subscription, and we have got the 2 driver, right? So if we are running, I mean, like me and
No,
Surendra are working
no,
together.
no, no. Not two drivers will be available. For this workspace, you have only one driver, one executor, multiple executors.
Okay.
And if you have different workspace, then you have different. Suppose now I have opened this thing. I have opened Saag Databricks. So in this Databricks, I can
Mhm.
create only, it will have only one cluster always for this Databricks, for this workspace.
Mhm.
You
So
have only one driver and multiple. Whenever, because this one was expand, okay, I'll create one account tomorrow because we need for analytics, Azure Synapse Analytics. That time I'll show you this one. But whenever you open anything, you have always only one driver for each
okay. So
workspace.
so
In
as
this
we compared,
workspace, you
yeah.
can't have two drivers. You can't select also that option.
Okay. So driver can increase the executor and decrease the executor also because
If you
driver
see
himself
here,
is not
yeah,
working.
yeah. Yeah, if you see driver type will be this one. So it will have only one driver. You don't have option to even increase the driver here, driver type. And for if you want more memory and more cores, you can select that, but you will have only always one driver.
One
If you
driver.
go for worker type executors, you
Hmm.
can always configure minimum 2, maximum 2. So you have option here to configure. So if I
Hmm.
have one KB file, I can use minimum executors one. So my job will get completed faster because I need only one worker node. If you have 10 GB, then I need more worker nodes to parallelize. Then I'll give maximum and minimum of worker nodes here. I'll configure. So based on my data, the worker nodes will increase or decrease. So
The,
even I don't have option here to restrict the driver. Only one driver, but I have option to increase the number of worker nodes or decrease the number of worker nodes here to achieve the parallelism.
sir, based on the size of the file, it will take care of the workers, how many workers required and all right, based on the minimum and maximum setup, correct?
Sorry, can you come again?
So based on the size of the data, so the driver will automatically identify the number of workers required for.
No, no, no. Driver won't identify. We need to provide that.
No, based on the for example, here the minimum workers we have been assigned as a 2 and max as a 2.
Yeah. If you do for auto scaling, this enable auto scaling, when you do this auto scaling, right, what happens? If you uncheck this checkbox, you'll have only one option to configure here.
Okay.
It's like suppose now you today I'm getting 10 GB data. I need 8 worker nodes. So you can configure 8 worker nodes, it will do. Next day, if you got only 1 KB file and 8 worker nodes are not required to process 1 KB file or 1 MB file. So you need only one. So in that case, it will use only one worker node. Remaining 7 worker nodes will be waste. So you are going to pay extra money.
Correct.
I want to, if I enable auto scaling, if my file size is 20 MB or 30 MB, it will use minimum worker node, that is 2 by default, and then it will process. Remaining 6 worker nodes, it won't charge. If you say data size is like somewhere 10 GB, then you need only 5 worker nodes for that to process 10 MB. So it will use 5 worker nodes, remaining 3 worker nodes, it won't be charged. So if you enable this auto scaling based on your workload, the driver will decide like how many number of worker nodes required for this. It will increase or decrease the number of worker nodes to achieve the performance. So this is one of the performance technique we have.
Yeah, I understand, sir. Now my question is, for example, the minimum workers we mentioned as the 2. Okay, it says that we have 1 KB of file. As per based on your prior experience, the only one worker is enough. But we have been configured here as a minimum workers as a 2. How many workers it will take for the 1 KB? It will take a 1 worker or 2 worker?
Whatever you have configured it to, it will utilize 2. But inside, when you are writing the data, it will take only one. It will other 2 worker nodes will be executed. But whichever the data that fits, because we have this 256 MB of block, right, in HDFS concept. So it will store that into one block, and remaining blocks will be filled with nulls or something.
Yeah, it will execute minimum 2 workers because we configured
you
like
have
that.
Configured 2, yeah.
But internally it can again assign.
You can give per one. In that case, you can give 1, maximum 1, and minimum 1 and maximum.
I understand, sir. Yeah.
So, sir, so basically, suppose we have big project, right? And we have some modules in that. So we will define different workspace for different module, and then we will start working.
Workspace for project, you are going to give 1 workspace for your project, like for your account. In the account, if you have multiple projects, you can always create multiple clusters. See, 1 cluster for 1 project, specific cluster you can create. But it's not like for each project I create workspace. No, for each account you can create 1 workspace, and that will be decided by your solution architect based on your organization structure, how it is. Okay.
Okay, sir. Because, sir, I mean, like, suppose we have a project where we deal with the daily load also, and we are dealing with the near real-time data also. So in
So
that,
your project, in your account, your project is just 1 project, right?
yes, sir.
But you have some 10 or 15 projects, correct? So I can't onboard 10, 15 projects under 1 account. So what they will do, if you have 10 projects, all the 10 projects will be created here, 10 projects, and you are going to write the code. But all these projects belongs to only 1 account, because if you create 10 workspace, at the end of the day, the billing will be go to the account manager. And he's handling 5 or 6 projects. You'll ask, okay, why can't you use everyone 1 account? Anyway, the billing will be calculated at the resource level. So I know how the billings will work for me.
Okay, so 1 subscription, 1 workspace is the
Yes. See, whenever you onboard subscription, right, you have all these details. You have only subscription. This Databricks workspace has been identified to this subscription. So you have subscription and all these things. Whatever you are going to execute is going to bill.
Yeah, actually, my question was like this. Suppose, as Surendra has given one example, that we are reading 1 KB file. So there are one driver, 2 worker node is required, right, sir? And suppose in parallel, some other person in the same workspace has run some command in any of the notebook. So that time, the same driver will go there and he will allocate some worker there, and his execution also will get started, right? Because we have some number of workers left in our account, like minimum is 2 and maximum is 8. what the configuration wish is, right? So 2 worker will work on the 1 KB file, and the remaining 6 worker will go to the other notebook, other guy, and then they will start executing. So there will not be
Yes.
any like other guys waiting for my job to finish and then
No,
his
no.
job
In the
will
same
start.
notebook, it will wait for to complete first command and second command will execute. But if you
Okay,
talk multiple other notebooks, the driver will take care of that. That is driver responsibility. You should not worry about how internally it will assign and all. The
no, no.
driver
If
will
someone,
assign
yeah,
that. Yeah.
yeah. If someone asks me the question in the interview, for that reason, I'm getting
See, like
clarification.
this, you have this thing. So if you go here inside the driver, let me see. So you have the VM. So in the VM, you have the data driver noder and you have the course like this. So if you go here, first driver program will analyze the code and all these things. The executor, you have the slots, where slots is thing, but you can store your data, 256 MB, 256 MB like that. Each executor will have some course. Inside that course, you have a slot. Okay. Inside slot, you have a task. Task is nothing but where you are going to fill the data to that one. So like this, whenever you have any data, so first you have the course like this. So if you see course is nothing but whenever you onboard anything right here. So here I have only 2 cores for this because this one, 2 cores means 2 slots I have to fill the data, 256 MB, 256 MB. If you have more cores for each driver, this is for driver config. And for cluster also you have the cores. So whenever you have the driver and executors, you have the cores which will come from the cluster. So once you have defined, so what happens? So after the course, the next is slot. Inside the core, you have a slot. Slot is nothing but you can store some data here. So once you store the data, that will be filled with the task like this. So the data will be filled. Now this executor is exhausted. So if you have another executors, so if you run another job, it will pick another executor, it will fill the data there. If you have 8 executors, until unless everything is exhausted, so it will take care of that. So if this before this complete runs, then it will clean up this thing and it will be ready for next execution. So you have a course inside the course. This is the course. So in the VM for the worker node, like 4 cores or 5 cores. So whenever the driver has assigned, driver will assign the slot whenever they want to execute some code. So once it is assigned, executor will execute and it will assign task to that slot and the task will execute it and the data is going to sit here in this task like this. That will be taken care by the driver. How I need to assign my executors to multiple notebooks. That will be taken care by the driver because there is a heartbeat between driver, program, and worker node. If anything that happened to the worker node, if it has been failed, it is slow, then it will call the nearby worker node and it is going to assign some work to that. That will be taken care by the driver. Driver is to talk every fraction of second. The heartbeat will be sent from worker node to driver node. So this is the concept of map reduce.
Sir, so can you just explain the core thing one more time? The core and then we are filling the memory and then task is slot is coming, then task is coming. There's something
See,
like
first, whenever the VM has been created, you have a
yes, sir.
course.
Yes, sir.
Okay, course is nothing but whenever we create the cluster here, whenever we create the cluster, for driver, I have 2 cores.
Yes, sir.
Okay, and for executor, based on the selection that you do here, if you go here, so if you see here, yeah, so if you see here, I have selected this VM, standard VM, DSV3, V2, okay. For this, it has 4 cores, means for each worker node, I am going to have 4 worker nodes, okay. Means if you are selecting 8 worker nodes, 8 into 4, 32 cores will be available for this. And this VM has only 4 cores. So total how many cores I have? 4 plus 8 into 4, 32. So total 36 cores I have. So if you see here, whenever the driver, the cluster is attached, then you will see this image. You have the driver and executors, and you have for each VM, if it is worker node 1, 4 cores, worker node 2, 4 cores, worker node 3 like this. So you have a course. So inside this core, whenever driver has been read some CSV file, so it is going to analyze. So what it will happen, it will read the code, it will read that program, and it will analyze, okay, I'm going to assign some task to you. so that that task will be called slot. So it is going to assign some slot to execute some code. So it will assign some slot for each and every executor. Once the slot is assigned, once the work is assigned, it will execute that code and it is going to fill the data with the task. So it will assign the task. That task will be executed like reading some CSV file, and that data will be returned to this code. So once it is filled, then this data can be returned to ADLS Gen 2 or ADLS S3 when you do spark.write dot your destination location. So the hierarchy will be, first you have codes inside the VM for that particular worker on a driver. So once the task is assigned, so it will, the executor will assign the slot. Okay, my slot is free. You can store some task for this. So the driver will assign the task.
So
Once the task
slot
is,
assignment is by driver or by executor?
this will be taken care by the driver.
Okay.
Only the task execution will be done by the executor. The data comes
Okay.
in. See how job should be divided, how many stages, that will be taken care by the driver. Only the
Okay.
task thing will be taken care by the executors for it.
Hmm.
So if you go here, I'll show you how the driver's multiple jobs will be executed. So let me run this code. Let me run this. So if I have able to create this cluster, right, I should have shown you all these things, but I need account for this. Anyway, we'll see that when we get new account. So now I'm going to read some file here. So I have the file here, text file. So let me read this file. Now when I run this code, this is going to submit to the cluster. Okay, this is going to submit to the cluster. So driver and executor will work here. So if you see my job, will first stage is job here. So if you see, whenever you submit anything, you will get the jobs. So how many jobs will be decided by the driver? So if I go here, so here I have only one job, and inside the job, I can have n number of stages. So if I see inside the job, I can have n number of stages. For each job, I can have one stage or stage two. So I have only one stage because this is simple file, and I have one task here. So this is task. Total number of tasks is executed one. So this task will be executed. So you can't see core and slot here. You can see directly slots. Jobs, you can have a number of jobs, particular one. And inside, for each job, you can have a number of stages. Inside stage, you can have a number of tasks. So if you see, this is like this. You can have a number of jobs, and each job can have a number of stages, and each stage can have a number of tasks. So this is how the flow will be. Now, I have read the some text file here. So now what I will do, now I am going to do something. Even if you run the same application, it will execute only one job for you. So what I'm going to do, I will just modify my code like data frame dot. I'm going to do some ordered by last name and select last name. So I'm going to do some transformations here. So I'm going to do this stuff. So if you see now for this job, it will decide like how many number of jobs are required, because I have used ordered by select. So I have used some kind of transformations here. So Spark will decide like how many number of jobs required. So if we see, first job is executing. Between that, the second job is also going to execute parallelly. So you'll see one more job will come here. So if you see still this job is running, second job came. So you can have n number of jobs, and each job can have n number of stages. Here I have 2 stages, and here I have 8 tasks here. So if you see, this is the task. So if you click on this view here, right? So I can I can see the stages here. How many stages I have? Only one stage. So this is the DAG, linear DAG. So this is the stage 1 I have. So in the stage 2, I have done this thing. Like how many tasks? So 8 tasks. Inside the stage, I have 8 tasks that are available. So like this, you can view the job here. And if you go for this, so you have 2 jobs. So job 1, job 2, you can have a number of jobs for particular code. And each job can have a number of stages. If you see, I have 2 stages here. And each stage can have a number of tasks that are available. So if you see why this has been skipped, right? Stage 2. Because this step is already performed at the stage 1, which is running. So this is skipped. So like this, if job 1 is already running, then it will skip that and it is going to execute stage 3. So this will be taken care by the Spark for you, driver, how the job should execute, which one to skip. So this is the hierarchy. You can have a number of jobs. Each job can have a number of stages, and each stage can have a number of tasks. So that is what we have seen here. So this is the workflow of Spark architecture. We execute through Databricks cluster. So any questions here?
Sir, whenever we select any cluster, it has memory. Like for a free version, we are having something around 15 GB. So that is nothing but just our cache memory, right? Or something else.
See, driver has its own memory.
Okay.
So if you do cache, then it will store the data in the RAM, in the driver memory. Okay. See, now whenever you store any data without cache, that will be the concept of data frame cache. It will store the data frame. That is the transformations. Data will hold temporarily until unless someone utilizes. If this cluster has been stopped, that data will be lost for you. But whenever you do the cache, whenever you are going to use that code again and again, then you need to attach that to the cluster.
Actually, what I want to understand is how this 15 GB is getting used by the cluster. That I want to understand.
See, that will be taken care by the driver and execute. That is the functionality of Spark.
Okay.
So based on the workload, it will decide, it will increase or decrease the thing. That is the beauty of Spark. You don't need to worry about how it works. You don't need to worry about how it is going to parallelize. Your main worry is my job is getting parallel process or not, and I'm going to achieve performance or not. That is what you need to see. If you want to dig internally, you should learn the Spark architecture. You need to learn some white papers. You need to learn how they have written code internally. So you need to learn that codes and all. But as part of data engineering, your work is to parallelize the job. Your work is to get the data. Your work is to do transformations, unload the data, build data lake. On top of that, you need to do analytics. You should not worry
Yeah.
about how it works internally.
Yeah, actually, my worry was, is it related to optimization of the things? So that's why I'm
See,
asking this
yeah.
question.
So whenever you create the cluster, right? Whenever you are going to create the cluster, okay. Whenever you are going to create the cluster, this driver, how much memory it is required. So for development, you can create just single cluster like one driver and 2 executors, and you can execute your code. If you want to do some performance optimization, then you need to look into the catalyst optimizer first. And second thing is you can increase your cluster memory based on your data size, and you can do that. But this cluster size, if you go for production, you should not worry about that because you are going to use job cluster there. We have two kinds of cluster right here. In production, you have two kinds of cluster. One is all-purpose cluster, one is job cluster. So in job cluster, you should not worry about this thing. Whenever your cluster started, it will execute your code and it will stop automatically, correct?
Yes, sir.
So you are going to save the time there. You are going to save the money. You should not worry about money. You should not worry about anything. It will, whatever the configuration that you have given, it will work on that. If you want performance more, you can increase that memory. That's it. But this job cluster, compute cluster, who is going to decide like how much memory I need? So this will be decided by your
System architect.
solution architect or lead who will get the size of the data. Based on that, they will configure your cluster accordingly. They'll give the configuration, so you need to use the same configuration. That's it. But whenever you are doing development, go for always small size. If you are doing some POCs, reading files, doing transformations. But uh, whenever you have huge load, if you want to do testing, then you need to first load with small data set and see performance like huge data set with small cluster capacity and see the performance. Still, if you are not achieved performance, then increase the worker nodes. Still, you are not there, then look into your code of repartition, all these things. So these are some of the ways that you need to do debugging on top of that and see whether you are using narrow transformation, wide transformation. So these things you should be taken care.
Okay, sir.
So you have the best practices here, follow. So if we click on this link, So for cluster configurations, if we go here, so we have best things auto scaling, which we have seen, and pools. I'll tell you. So what these pools is, right? Have you observed whenever you are going to onboard any cluster here, whenever you are going to onboard the cluster, whenever you are going to create this cluster, it will take 2 to 3 minutes of time, correct? 2 to 5 minutes of time to start this cluster,
Yes, sir.
correct? So what happens if you go for pool? So pools reduce the cluster start and scale up time by maintaining the set of variable ready to use instance. So what happens? This pool will have some ready to use instance. So whenever you are going to use these pools, so in the pools, I have created some pools. So when I create the pool, name ideal time, like ideal time, what is the ideal time that you want to be available, ideal time, and terminate after how many minutes, and what is the driver type, and preload this one, so you can have the database version. So I will configure this thing and it will be up and ready for me to use. It will be ready for me to use. Whenever you call, the cluster, whenever you start the cluster something, if that configuration is already available in the pool configuration, it will get from here and it will create the cluster immediately. Earlier, if it is taking 5 minutes to start, whenever you go for pools, then it will start immediately for you. So it is going to save our time, reduce the cluster start and scale up time for us, this cluster pool. Okay, so this will be used for production workloads. So whenever first you learn basics, once you're comfort with basics, then we need to, I have told you optimization techniques. One is repartition collapse, one is catalyst optimizer, right? And one is this cluster auto scaling. So you have this auto scaling here. So you need to look into this auto scaling option as well always. You should always enable this auto scaling, which is available here. Okay. And you should take care of your partitions whenever you're manually providing.
Sir, in
And then,
real-time scenario, I'm like a solution architect will give that you need to use these many worker for this job, right? Or we
yes,
are going
yes.
to decide that.
No, you are not going to decide that. Okay. Your solution architect will, because you are doing development. In development, always you are not going to do with real-time data. First of all, you should keep in mind.
Mhm.
Second thing, you are going to get some dummy data, which is generated by Faker library, which is available in Python or any other tools. You get some 100 MB, 100 MB files, and you process that files, you transform these files.
Mhm.
But whenever you want to do some kind of performance testing, then you need to generate huge data. And even production, if they are facing anything, your lead or solution architect will provide you the solution. Like please
Mhm.
go with this kind of configuration so that it will, you can achieve performance. Or database team will provide you. If you provide the size, they will ask you to go with this configuration.
Okay,
Okay.
sir. Yes,
So
sir.
if you
Got it.
see, there are two kinds of cluster: all-purpose cluster and job cluster. If you see all-purpose cluster, you can create the clusters here, and this will be used for development purpose. You can create manually here, so it is not created automatically, and it is persist always for you. And you can interactive workload. So this purpose all cluster, when you create here, right? So I have created some cluster here. So I can use this cluster to attach to multiple clusters. I can execute the queries manually as well. That is what interactive workloads. And I can share among the users. So if I want to share this cluster, I can share that access to someone. So if I go here, so I don't have option here in the single node cluster. But when you go for here, so I can share this cluster to multiple users. So I can add n number of users here. Suppose I want to provide access to another user, I can add this access to user. So I can restrict the users as well to use here. So that is what in all-purpose cluster, you can share among many users and expense to run, because everyone can create. Suppose if you have five developers will create their own clusters. So it is expensive. So this is about all-purpose cluster and job cluster here. So it is created by the job. So whatever you configure in Azure Data Factory, based on the configuration, these jobs will be created, terminated at the end of the job. So whenever the job completes, automatically it will terminate for you. We have seen this, and it is suitable for automated workloads. So this is suitable for only automated workloads, and it's isolated for your job. Okay, and it is cheaper to run, and you can save the cost. So these are the two types of clusters we have. And if you go for cluster configuration, so you have two kinds of cluster configuration here. Whenever you go here, this image, right? So you have single node cluster, you have multi-node cluster. Single node cluster means you have only one driver, you don't have any worker nodes. So this single node cluster will be used for doing POCs, and multi-node cluster we use for doing general purpose development things and all in real time. So if you see, this is single node cluster which I have created here. So I have only one driver, I don't have any executors. But if you go here, if you select multi-node cluster, you have the concept of worker and driver. So you can configure this, and you have auto scaling as well, which I have discussed. And you have one more option called terminate after 120 minutes. What is this terminate after 120 minutes? If this cluster is up and running for 120 minutes, I have created this cluster. Suppose I have created one cluster here. I have created one cluster here, which is available here, right? So if my work is only 10 minutes, I have done my job. I forgot to stop this cluster. I have forgot to stop this cluster. So what happens? Databricks will be keep on charging for this. So if you see, this is the cost. If you see here, so it is a cost here. It will come here. So here it is. Okay. This image, it will come here. This is the performance. So if I go here, right? So if you see here, so usually the cost will come here per hour. The charge. This is single node cluster, so we don't have this option. I think I have that screenshot for you. 1 second. Get that screenshot. Yeah. So if you see, if you have one driver and if you have multiple executors and you are going to use this VM, they are going to charge 0.75 Databricks units per hour. Means they are going to charge $0.75 for only one driver and you have runtime. So if you have more number of worker nodes, then it will calculate accordingly, like number of DBUs, Databricks units. So what is this Databricks units in the sense? Whenever you configure here, so Databricks runtime. So here I don't have that screenshot. Let me go here. The same thing. Yeah, here you have Databricks runtime version. So here, based on this units, Databricks runtime units, how much they are going to charge, it will charge accordingly. So if I go here, number of DBUs and price based on the workload tier is equal to DBU cost. So that is driver cost and worker node cost. So you have cost for driver, you have cost for DBU, Databricks units and worker nodes, and the final cost will be the for the cluster per hour. So this is like one driver, number of worker nodes into price of VM, and they are going to charge for you. Suppose if you see here, Databricks for all purpose cluster, the DU price per hour is 0.4. So you have two things, standard tier and premium tier. So if you use standard, this is 0.4. If you go for premium, you have some extra features in premium. They're going to charge $0.55 per hour. If you go for job compute, so this is C. The pricing is very less for this. So DB units per hour 0.15 means 25% of price is decreased here. $25 price is decreased for me. And this is 0.3. Job light. So these are the clusters we have pricing. And if you go for pricing, so if you see, if you take this is the DSVM instance, and if you have one CP and this much of RAM and temporary storage, if you take pay-as-you-go subscription per year, per hour, it's going to charge this much. 1 year subscription, it will be a little bit less per hour. If you go for 3-year plan, then you have 31%. So based on your configuration, the Databricks is going to charge for you. The Databricks is going to charge for you. So it's purely configuration driven. So if you configure less, you're going to pay less. If you configure more, you're going to pay more. But you should be very, very, very careful whenever you are going to see. If you see, I have one driver, I have 3 executors, and I use this Databricks runtime, this one. So based on this calculation, based on the VM, it is going to charge 3 DB units per hour. So this is how the pricing is taken care in the Databricks. So any doubts here?
No, sir.
Fine, sir.
So these are the things that you should know as part of data engineering in the cluster. So when I get this cluster, right, when I get account, so next week I'll create one account because I didn't get money, I didn't get salary. So I'll get salary only after 25th. Okay, 25th I'll get salary. 24th I'll get because 25th is holiday. So I'll get my salary on 24th. So once I get money, right, I'll create one account, $150 and I will provide you that account. Anyway, we need that account for Synapse Analytics, which we are going to use. Okay. That time I'll show you all these configurations in the workspace because I need real-time workspace here. Okay, for that. So this we have done with Spark. So now it's your time to complete all the Spark workloads which I have shared. Okay. So going forward, you just explore. You need to explore lot and lot. If you have any questions, let me know on Spark. Okay, I have shared already 65 questions to you. Just go
Yes,
through
sir.
that 65 questions and then go through different websites for Spark interview questions. Then only you learn. Okay, and
Yes.
search different kinds of optimization techniques in Spark. So already I have told 4 to 5. So you need to keep on learning and keep growing on top of that. Okay.
Yes, sir.
Yes, sure, sure.
Yeah. So tomorrow we'll start Delta. Okay, that is advanced topic which we are going to learn from tomorrow. Okay.
Yes, sir.
That is Synapse Analytics or